The next style equation we're going to look at are equations with rational exponents. And actually, rational exponents are really just another way to write roots. So for instance, if you see a rational exponent, rational just means ratio. So you have a fraction on your exponent. You actually can write it as a root. So just for instance, let's say I have something like x to the 4/5. That is the same thing as having the 5th root of x to the 4th power. Or I can write it like this, the 5th root of x to the 4th power. So that exponent could either go inside or outside the root, it doesn't matter. But the key thing here is that your denominator is basically always the root, and then the numerator is like a regular exponent. So it's just another way to write radicals. And you're going to see that when we're solving, we're going to use a pretty similar strategy where we're going to start by isolating that rational exponent first, just like we isolated the radicals in the last video. So we're going to isolate the expression with the rational exponent, so get that by itself. Then you're going to raise both sides of the equation to the power that is the reciprocal. So again, we want to cancel out that exponent, so we're going to use the reciprocal, which is the flipped version. Here's where it gets a little bit tricky. If your m is even, so if your top number here is even, then you would use a plus or minus symbol when solving. And if your m is odd, then you would only use the positive or whatever root that you have as your answer. So that's one thing to keep in mind. And if you think about it, when we are solving things that have like x squares, we typically get two answers, right? When we take the square root, we do a plus or minus there. So that's why it's because you have that even power. So let's go ahead and try these out. Also, just like with radicals, you can get extraneous solutions. So you do want to go back and check your answers. All right, so I'm going to add 6 to both sides and divide by 3 first. So again, we're not starting in the equal 0 form. We actually want to isolate that rational exponent. And then what you're going to do is you're going to raise both sides to that reciprocal. Because that's how you get it to cancel, right? The 4s and the 3s will both cancel. And then I have x is equal to 2 to the 4/3. Now, we can simplify that if we want to. So I guess we'll leave it like this for right now to check. But you could also write this as the cubed root of 2 to the 4th power, or the cubed root of 2 to the 4th power. And we could simplify a little bit more there if we wanted to. So the 2 to the 4th power would be 16. You could write this as the cubed root of 16. We could even break that down and keep solving. So your book actually just leaves the answer as 2 to the 4/3 or like this or this. So I'm going to stop there. But you could keep breaking this down a little bit further. The other thing you could do is you could also use your calculator. So let me show you that before the check too. Now, the nice thing is that if you have a, at least a somewhat advanced calculator that can do exponents and has parentheses, then you actually can do this in your calculator. So you would just type the 2 and then use your exponent key. And then just make sure you put your fraction in parentheses so that it knows to stay up top, and you can get an approximate answer there. So if you want the approximation, it's about 2.52 here. So it is a number. All right, so I'm going to leave it like this because, again, that's how your book leaves it, even though we could actually simplify that a little bit further. And I am going to do the check, though. So your x value here is 2 to the 4/3. And that was raised to the 3/4 power minus 6 equals 0. So you're going to notice that my exponents are canceling. So this is really just 3 times 2 minus 6 equals 0, which is true, right? 3 times 2 is 6, minus 6 is 0. So this does check out here. As a little side note here, for those of you who are used to simplifying, remember that 16 is the same thing as 8 times 2, right? And 8 is actually a cubed root. So if you wanted to, you could actually break this down into 2 times the cubed root of 2. So just like we simplify square roots sometimes, we actually can simplify cube roots as well, looking for a factor that is a perfect cube. So just a little bit further there for those of you who are used to simplifying your roots. Okay, let's go ahead and do the other example here. Now you can do a few things. If you want to cancel your fraction here, you can. So we can multiply everything through by 4 and cancel that fraction out. This one's actually a pretty simple one. So -1/2, if I multiply that by 2 over 2 is just -2 over 4. So we actually could just simplify this pretty quickly here. So if I bring that 3/4 to the other side, I have x to the 2/3 is equal to +1/4. So normally I would cancel fractions, but because it's just one step here and that 1/2 is pretty easy to work with, you could do it this way instead. So whatever you want to, but either way, even if you cancel first and then you keep simplifying, you should still get to this step here. And now what we're going to do is we're going to raise both sides to that 3/2 power. So we get x equals 1/4 to the 3/2 power. Now, one thing to note here is that, again, you could rewrite this. So the root is a square, so it's the square root of 1/4 to the 3rd power, but we can actually simplify the square root of 1/4. The square root of 1 is 1, and the square root of 4 is 2. So this becomes 1/2 to the 3rd power, which is just 1/8. 1 to the 3rd is 1, 2 to the 3rd is 8. And again, in this case, you want to be careful because that top value here is even. So when you have that even exponent in the numerator, you want to add in that plus or minus with your answer here. So I am going to go ahead and add that as well. This one, we didn't have to do it because our m was odd. So when your m is odd, you don't have to add in the plus or minus. You just have one solution. When your m is even, 2, 4, 6, 8, etc., then you do have to add in that plus or minus. You also want to simplify if you can. So if the problem is easy to simplify, then I suggest you do that. This one was pretty challenging. It doesn't come out even. You clearly get an answer that is a decimal. So if you get a decimal answer, then just simplify as much as you can. But for those that come out nice here, we can get a nice fraction that does not just keep running on forever, then we should do that. So we have our 2 answers here. Now we can go through and check this as well. So if you want to check it, you can check it with the 1/8 and go ahead and plug that in. Or you could always go back and check with the 1/4 to the 3/2. So it's probably easier to check your problem when you're in the rational form first. So I would do 1/4 to the 3/2, and that was all to the 2/3 power minus 3/4 equals -1/2. So what happens here is you're going to get that canceling. 1/4 minus 3/4 is the same thing as -2/4, which is -1/2. So it does check out. The negative version checks out as well. So that one may be a little bit harder to see with the negative version here. Okay. But with the negative version, you're going to just, again, plug in a -1/4 instead here. And the reason it checks out is because when you raise it to the 2/3 power, you have a square here. So that negative is going to square out and give you a positive as well. So it's a little bit harder to see when you're checking some of these. They are pretty tough, but if you go ahead and you try that, that square is going to take that negative and do it twice. So you are going to cancel that negative out. So they are both going to check out here. So you have 2 solutions, positive and -1/8. If you're going to check using the original, again, just make sure that you haven't made a mistake here along the way. So if you're uncomfortable with that, you can always plug the 1/8 in to start and the -1/8. And then just do out the radicals there to figure those answers out. But if it's easier, you can check with this. And again, just make sure that you haven't made a mistake in the simplifying later on. The next style equation we're going to look at are equations in quadratic form. So an equation that's in quadratic form is one that can be expressed as a quadratic when we use a substitution there. So basically they look like they're almost quadratics, but they're like a little bit off. So here's an example here where you're looking, and if you're like, well, if I just got rid of that denominator, then I have a quadratic, right? I have that x squared, I have the x to the first power, it would make sense. So it looks like it's almost in the right form. What we do is we make a substitution here to fix it because we know how to work with quadratics. So what we typically do is you're going to let u equal whatever sort of like this piece is here. Okay, so you're looking at that middle piece to figure, okay, what should my u be equaling? Because you want it to just be an x. So it's not just an x, it's x to the 1/3. So we're going to let u equal x to the 1/3. Then what happens is u squared is equal to x to the 1/3 squared, which is the same thing as x to the 2/3. When we multiply here, remember you multiply straight across. So this is 2 over 1. So 2 times 1 and then 3 times the 1 in the denominator. So I'm going to replace the x's here with the u notation. So I have 5, and then instead of x to the 2/3, I'm going to use u squared. Here, instead of x to the 1/3, I'm going to use just u. And then now you can see that it looks like a more normal problem. I know I've changed my variable. Typically, we do use u for substitution rather than something else. And again, typically, if you just look at that b term here, this is sort of going to tell you what your u should be. Sometimes you get a little bit more complicated, but overall, looking at that b term, you just want it to be normal x. So using that usually helps. And then now what you can do is you can solve this as a regular quadratic problem. Okay. All right. So here, again, look at it and say, okay, how can I solve this? This one actually is factorable, so I'm going to factor it. But if you get stuck on factoring, you can always use the quadratic formula. So for here, my possibilities are 5u and u. And then here for +2, it's either 1 and 2 or -1 and -2. So I don't have too many options for the trial and error method. Let's see, 1 and 2. I want a +11 in the middle, so I'm going to use positive signs here. And again, I'm going to multiply this out to check. So if I were to FOIL this out, I would see I get a 10 plus 1 in the middle, which gives me the 11. And again, you can do the complete FOIL out as well, just to make sure you haven't made a mistake. Once we have that, then we can set each piece equal to 0 and solve. So here I'm subtracting with 1. Here I'm subtracting with 2. Here I'm dividing by 5. And I have my 2. Sorry, it should be a negative. Let's write this again, -1/5 and -2. Now you just want to be careful here. When you use substitution, you actually have an extra change that you have to make. Our answer isn't just u equals -1/5 and u equals -2, because our original problem had x's in it. So you need to substitute back in. And remember that u is equal to x to the 1/3. So this actually means that x to the 1/3 is equal to -1/5, and x to the 1/3 is equal to -2. So to finish this, you want to make sure you have just an x here. So in this case, I can cancel this out by raising this to the 3rd power, right? Because 1/3 times 3 will cancel. And x to the -1/3 power, well, I'd have -1 to the 3rd power is -1, and 5 to the 3rd power is 125. Again, I would cancel that exponent out here, raising it to the 3rd power. So this is going to cancel. And I have x is equal to -2 to the 3rd power, which is -8. -2 times -2 times -2 is going to give us -8 here. Okay. So, and again, notice here as well, I just want to make this comment that remember when we're solving for rationals, right? If your top number is even, you would use a plus or minus sign. But our top number is odd, so I don't have to worry about that here, right? Our top number is 1. So when I raise it to the 3rd power, I'm not going to have that plus or minus sign. So I have 2 answers here. Now, in this case, because these were rationals, right, we just solved rational exponents, you do need to check for extraneous solutions. Okay, so if you have anything that you're solving with rational exponents, you do need to go through and check for extraneous solutions. I'll save us a little bit of time here, but if you actually check both of these values back into the original equation, they do work. So you are all set there. Another thing too is as you're plugging in, if you have a hard time doing your radicals by hand, you can always use your calculator to help you. So like for instance, if I was checking that -8 here and was trying to figure out, well, what is -8 to the 2/3 power, you could use your calculator to help. So just put the -8 in parentheses, raise it to the 2/3 power, again, using parentheses for the exponent, and it will give you that answer. So here it is going to be 4. And the reasoning is because the cubed root of -8 is -2, and then when you square that, you get +4. So you can still break it down if you want to by hand. But again, if you're getting a little bit stuck, you can use your calculator to help you. You just have to make sure you use lots of parentheses. So parentheses around negatives and parentheses around exponents, particularly depending on which kind of calculator you have. Okay, so you can check at home. But they both work. So they are both going to check out and be true solutions. So here, again, if you look, we're almost in the right form. I see that something is being squared and that same something is to the first power. So it looks like it's almost a quadratic. So what you're going to do is let this piece be your u. Okay, so we're going to let u be x squared minus 5 here, and then u squared would be x squared minus 5 squared. So I'm going to replace this. So this first piece becomes u squared plus 3u minus 10 equals 0. This one also happens to be factorable. So if you factor this, let's see, we have u, and then for 10, it's either 1 times 10 or 2 times 5. To get the 3 in the middle, the 2 times 5 is the one that's going to work. And I want a +3, so I will use a +5 and a -2. If I FOIL this out, I'll see that I do get the original equation here. And again, if you need more practice on factoring, you really want to go back and review that. There's a lot that we do with factoring in this course. And so I just keep solving and I get u equals 2 and u equals -5. Now you do want to go ahead and substitute back in, right? Because our answer is not u, it was supposed to be in the x format. So u is x squared minus 5 equals 2, and then x squared minus 5 equals -5. So solving this, I would add 5 to both sides here. X squared equals 7. Taking the square root of both sides, don't forget the plus or minus, we get x equals plus or minus the square root of 7. Here, adding 5 to both sides, I have x squared equals 0. And then when I take the square root, again, it's technically plus or minus, but 0 is neither positive or negative, then we're going to have 0 there. So here I have my solutions. Okay. Now, in this case, you technically don't need to check because we didn't have any rational exponents here. I didn't have any radicals to start with, right? So the two things that we really have to watch out, or I guess a few things, but the rational exponents, those radicals, and then from before when you have x's in the denominator, we have to check all of those. This one we don't technically have to check. I didn't have anything like that going on, but it is always good to still check your answer. So I'll let you do that check at home. I will note here that I did skip over number 6 in your text, which look like this: x to the 4th minus 8x squared minus 9 equals 0. So this one, again, is that same style. So it looks like it is of a quadratic, but the exponents are double what they should be. So this right here is going to be your u. So you would let u equal the x squared piece And then u squared would be x squared squared, which is that x to the fourth. So when you make the substitution here, you're solving u squared minus 8u minus 9 equals 0. And I'm going to encourage you to go read through the rest of that in the text. At this point, I think I did the two harder ones. You could see those. But this one, you can go ahead and factor and solve just like we have been doing, and then substitute back in at the end x squared. So you'll be able to do that there. And you will see that you do have 4 answers there as well. So you'll have positive, negative 3, and then you actually have a complex solution, positive or negative 9. Okay, so check that one out in your text too. And if you have questions on it, let me know. But it works the same way. So at this point, you could solve by the quadratic equation or just factor, and then just don't forget to set your answers equal to x squared and keep solving from there. So just like we did here, it's actually kind of very similar to this part right here. Once you have your answers, you're going to take that square root at the end to get your final results.